Welcome to vFabric TC Server, a cloud-ready Java application server platform. TC Server combines the best of lightweight technologies such as Apache Tomcat and enterprise features that we use to in Java enterprise application server environments. TC Server has a lot of features. One, the cost is a fraction. Any company wanting to move into a cloud environment needs to have elasticity, dynamic scaling. Cost is going to be a huge feature. It bridges the gap between developers and operation teams, allows for root cause analyses in an environment that's familiar to both departments. And it's cloud ready. Its lightweightness, its nimbleness, its speed, its performance, its ease of use makes TC Server the ultimate platform in cloud environments. Today we're here to talk about an exciting new feature, EM4J, or Elastic Memory for Java. Let us explain how vFabric TC Server has solved the problem of overcommitment of Java workloads in virtualized environments. We're all familiar with a popular concept called ballooning. This has allowed us to consolidate workloads into virtual environments. Tier 2, Tier 3 applications have greatly benefited from a cost perspective, from a resource perspective, from a management perspective. This has never been possible with Java. Let us explain why. Java manages memory. Memory is a direct pattern from application workloads. Workloads can vary. They can vary based on day, based on hour, based on day of week, based on season. There can be many different patterns to workloads. When we have small workloads and we can predict workloads, we can consolidate these resources. We know how many Java workloads we can fit on a vSphere host. We can do so by keeping these workloads small. The problem is, what about peak workloads? Take an example, Butterball Turkey. A very interesting website because it does have a seasonal effect. 2 weeks out of the year, this website receives a tremendous amount of traffic. 50 weeks out of the year, it still receives traffic, but a lot less. So how do we provision for a website like this? With Java workloads, our best practices so far has been to never overcommit these resources. We have to plan for peak workloads. This does not work well in a virtual environment. If we can't get the consolidation, where's the benefit of virtualizing Java workloads? Elastic Memory for Java has solved this problem. We can still right-size our Java workloads, but with vSphere and Elastic Memory for Java, we are allowed to share these resources. Let me walk you through how vCenter and vSphere handle these memory sharing on true Java workloads. Today, we'll show you an ESX host, 5 GB of RAM, but 6 JVMs all taking up more than 7 GB of memory. The balloon concept to a vSphere administrator looks exactly the same as it done in previous versions, with the exception that today's environment and a Java workload, we're actually using a Java balloon. This is the Elastic Memory for Java. When we look at a specific JVM inside of vCenter, we can see that the balloon is inflating and then deflating. This is the pattern we will see for a JVM that releases memory and reclaims the memory right away because its workload is increasing. In an environment where Java workloads are active, idle, or switch back and forth, the goal of our overcommitment is that we'll never swap. Our example, our 5 GB of RAM used by 7 GB of Java heaps, no swapping happened. And that is just one of the new exciting features in the vFabric Cloud Application Platform. Thank you very much.